Okay, now we are going to look at the molecular model for acetic acid. Acetic acid has 2 carbon atoms, and you can see that the first one has these 3 hydrogen atoms associated with it, and then you have a COOH. Okay, so this right here, the on this final hydrogen ion here, this one is the one that is lost or associated. So this becomes the anion, and this becomes the cation when this goes into solution. This is a double bond to this one oxygen and a single bond to this one. So you see that each carbon has, this carbon has 4 bonds associated with it, and this carbon has 4 bonds associated with it. 2 single bonds, 1 double bond. This oxygen has 2 bonds associated with it, and this oxygen has 2 bonds associated with it as well. So on this particular one right here, what you have to make certain about is that you are drawing it. These two are going to be in a straight line here. This is going to be sort of on a straight line here, but this is going to be downwards, and then this is going to be out to the side. Okay? So this is just slightly off the page. This is on the page, and these two are on the page as well. This is setting up somewhat. This is a straight parallel across from it. This is coming out of the page, and this is out of the page as well, but it's sort of at an angle over there because you've got the 2 bonds tied to that one. And this one right here is on the page, but that raises this one up just a little bit. So the first thing to do is to draw these as well as you can on those models. Okay? Then what you're going to do is you're going to utilize these as follows in the next section. So these are the reactants and the products of combustion. We've done this one. The oxygen is essentially 2 oxygens bound together, right? Then we form carbon dioxide. We've seen how that one looks, and you've seen how water looks. So we've had the methane. So what I want you to do is then make models of these to show how this sort of reaction takes place. Then also, this is the reaction between acetic acid and sodium hydroxide. This is just sodium, and this is oxygen with a hydrogen. And these two are in an aqueous solution. This is just as the Na plus ion, and this is an OH minus ion. And this right here is water again. And so this one right here has all of that acetic acid molecule except for that one hydrogen. And that's replaced with this sodium atom right here. Okay? So I want you to make the models for each of these 2 things. And for the sodium, just use a different colored sphere. Usually it's a gray color or something like that. Gray is usually the color for a metal ion. Okay? Now, then what I want you to do is to look at what is the difference in geometry for the difference between water and the carbon monoxide. Each one of these has a central atom and 2 atoms bonded to it, but they are very different in their geometry. Okay? So you need to explain that here. To the equations of the second task, follow the laws of conservation of matter. And how could you determine that? Okay? Answer that question. Then I've got something here a little bit different. What I want you to do is we've got several ones that belong to the same family. You've got aldehyde or amphetamine here. You've got our friend meth right here. Okay? And then you have cocaine. Okay? And you can see some similarities between these. And what I want you to do is from these structures, I want you to note the similarities and the differences. Okay? So, for example, each one of them has this type of a ring structure. This is a benzene ring. Okay. Each one of them also has, this would be a line out here. That would mean there's a carbon located here, and there's a carbon located right here. And this has, from this carbon, you have a methane group down here, and you've got an NH2 up over there. Here you've got that same type of structure with a methane down here, but instead of this NH, you've got this methyl group replacing one of those hydrogens, don't you? That methyl group is what makes this methamphetamine instead of just plain old amphetamine. Now let's look at something that's quite a bit more powerful as a stimulant, and that's cocaine. Here, there's a few different changes. You've got a methyl group off over here. This right here, instead of having two hydrogens off of this carbon, you've got a double bond O. And you still have this same type of a function here that you had with the methamphetamine. So the changes from methamphetamine to cocaine are essentially just adding oxygen with a double bond here and a methyl group over here. Okay? So anyway, you can compare the difference between them, and those little differences make all the differences in the world in terms of how they react to your body. The next one. Here you're looking at three different types of pain medication. Aspirin, which is acetyl salicylic acid, okay? And then you have Tylenol, which is acetaminophen, and Motrin, which is ibuprofen, okay? So three different ones. These two are both non-steroidal anti-inflammatories. This does not belong to that group at all, okay? Ibuprofen is quite a bit different than those other ones. And so point out that what you see as similarities and differences between these different groups. And then finally, the last group you're going to look for are different ones that are known to be destructive of the brain, although they have some use to relieve medically to relieve nausea, but only that. If you are taking them for depression, it's not going to really work because they actually make you more paranoid. Okay, one of these, and only one of these, has not been shown to be psychoactive. The other ones are all psychoactive, and they are more restrictive. The other one is allowed, and that is CBD right here, okay? These other ones right here are all hallucinogenic materials. And you can see what the difference is. THC, which is the primary one, tetrahydrocannabinol, is this one right here. Okay? What's the difference between that one and this one? Well, essentially, here you have 1, 2, 3, 4 carbons there. Here you have just 1 and 2 before you get to this one. Here, this one looks fairly similar as well, but you'll notice that you've got an extra double bond right here, don't you? That's missing from here and here. These two are very similar to this one right here. This one is not psychoactive, and the difference is this broken bond right here and a methyl group and this group out over here. So instead of two methane groups on this one, you've got a double bond and a CH2 over here. This bond is broken, and you have an OH group or an alcohol group off of this, and you have a CH3 or another methyl group coming down from this one. Okay? So that's the only difference, and this keeps it from interfering with the brain. These are other ones that have various degrees of activity, and this one's just I have no idea what the psychoactivity of this particular one is. But this one right here, essentially what you've done is you've opened up or had additional things added off of this particular one right here. Instead of a hydrogen here, instead of a double bond here, what you've done is you have an oxygen there, and then you have this whole chain over here for CBC. Okay? So anyway, what I want you to do on these is look them over carefully. Note similarities in structures and differences, and then any conclusions you might want to make. And that's the end of the lab for today.